good afternoon, students. In this lecture, we'll be learning about association rule and frequent patterns. Frequent patterns are patterns that appear frequently in a data set. For example, a set of items such as milk and bread that appear frequently together in a transaction data set. So whenever you go to market and buy some things together, then those items which are frequently bought by several other customers, they are called as frequent item set. Now, a typical example of frequent item set mining is called as market basket analysis. So what this market basket analysis does is, this process analyzes customers' buying habits by finding associations between the different items. So whenever different items are purchased together, then those associations are found out in the market basket analysis. As you can see in this figure, several customers have put different items in their baskets. Like first customer has put up milk and bread and cereal, second has put milk, bread, third has also put up milk and bread. So depending upon what the customers are putting up in their baskets, we can identify which items are purchased together. So this is called as market basket analysis. So whenever some items are put up in the basket, then every basket contains those items, and those items can be represented by a Boolean vector, and some value is assigned to those variables. Now once the vector which contains all those variable values, this can be analyzed for buying patterns, and those patterns reflect that which items are purchased together. So whenever those items are purchased together, they are represented in the form of association rules. So when I say association rules, that means this is an example of an association rule. This says that whenever a user or a buyer buys a computer, he also buys an antivirus software. So this is what is called an association rule. So association rule is a kind of representation where we can represent different items which are bought together. Now along with these two items, we here see support and confidence. So what are these support and confidence? So support and confidence are the two measures of rule interestingness. So whether this rule is of some usefulness to us or not, this is measured with the help of rule interestingness metrics. So here we see support 2%. What this 2% means is that of all the transactions under analysis, like there are 100 transactions, if there are 100 transactions, then out of those 100 transactions, only 2 transactions have computer and antivirus software which are purchased together. So this is called as support. So whenever we compute support, we consider the total number of transactions and both the items which are written in the association rules. If they are purchased together, then this forms the support. Now another term we see here is confidence, and here we see that the confidence value is 60%. What does this mean is that 60% of the customers who purchased a computer also bought the software. So here we have a condition that the first item, if the first item is bought, then how many those transactions are, and in those transactions how many of those transactions they bought the antivirus software. So here we have a condition that if the first item was bought, then how much is the probability of the second item. So here this is represented as 60%. Now whether this association rule together with support and confidence is of interest to us or not interest to us, it is measured by some minimum support threshold. Now this support threshold value is for both support as well as confidence, and these threshold values are set up by users or the domain experts in the field of data mining. To represent mathematically the values of support and confidence, we can represent them with the following formulas. So if I write A arrow B, then and this rule has a support of S, that means S is the percentage of transaction in the total database that contains both the items, and if I say both the items, it means A union B, and this is taken as a probability of A union B. If I say that the rule A arrow B has confidence C, then in the transaction set, then what I mean is that what is the percentage of transaction in in the total data set that contain A and they also contain B. That means the necessity of item A is essential. If A is there, then out of those transactions, in how many transactions the item B has been purchased together. So mathematically, these support and confidence can be represented by equation 6.2 and 6.3. And as we have learned earlier, that these rules can be called as strong rules if they satisfy the minimum support threshold and minimum confidence threshold values. Now when I try to find out minimum support threshold, then one another term comes that is called as a support count. So the occurrence frequency of an item set is the number of transactions that contain the item set. If suppose there are 10 transactions and out of those 10 transactions there is milk in 3 transactions, then I can say that the support of milk is 3. So support counts the frequency of an item set in the transaction. So this is also termed as frequency or support count, or only the count. The confidence can also be represented in the terms of support count, and as you know that probability of B given A can be represented by support of A union B divided by support A. So this is also one of the equations which is used to calculate the confidence. Now whenever we try to form association rules out of these threshold values, and what we do is, we first of all, it is a two-step process. We first find all the frequent item sets. And what is a frequent item set? So a frequent item set is an item set which has an item at least greater than equal to the predetermined minimum support count. And from all those frequent item sets, we generate strong association rules. And what is a strong association rule? A rule is strong if it satisfies both minimum support and minimum confidence. So frequent item set only requires minimum support to be fulfilled, but when we talk of strong association rules, then it means that both the support and minimum confidence threshold should be met. Now for finding out the frequent item sets, we have one algorithm, and that algorithm is called as a priori algorithm. So this algorithm is a basic algorithm for finding frequent item set. And as the name suggests, a priori, that means this algorithm uses prior knowledge of the frequent item set. So this algorithm, what it does is, it employs an iterative approach. It loops again and again, and this is known as a level-wise search. So in every loop, in every iteration, what it does is, it searches for the items. Now which item does it search? It searches the k item sets, and these k item sets are used to give k plus 1 item set. So first the set of 1 item sets is found by scanning the database. So whatever the database is, we go through the database and find out which items occur how many times, and if those items occur, the number of times those items occur is greater than the minimum support count, then we add those items in the frequent 1 item set list. So when we collect all these items that satisfy minimum support count, now this gives us the L1 set, and this set can be represented as L subscript 1. Now from this first L1 set, that means this 1 item set, this set is used to find this 2 item set. This is termed as L2, which in turn is used to find out 3 item set, and until no more frequent k item sets can be found. So for finding each LK, what we require is, we require to scan the database again and again to see whether, if it is a 2 item set, then how many times both the items occur. If it is a 3 item set, how many times all these 3 items occur in the entire database. So we need to scan the entire database every time whenever we try to find out LN item set. Now in order to improve the efficiency of the level wise generation, because we are scanning the database again and again, we use an important a priori property which tries to reduce the search space. So this search space is the previous item set. So if I say, if I am trying to find L3, then L2 is the search space. If I am trying to find L4, then L3 is the search space. So what this a priority is used it is the property that says that all non-empty subsets of a frequent item sets must also be frequent. So what this means is, if I have a 3 item set and in there are 3 items I1, I5 and I7. Now what is required is that each of the individual items I1, I5 and I9, they all should also be frequent. So this property is called as a priori property. This property helps us to reduce the search space and this makes the algorithm work faster. So this property belongs to a special category of properties, and this property is called as anti-monotonicity property. And then in this sense it says that all the supersets will fail if the same test as well. So superset will work only if the subsets work. So let us see that how this algorithm works. So this algorithm is a two-step process. In the first step it is called as the join step, and in the join step what we do is to find the item set Lk. What we do is we find a candidate k item set that is generated by the previous number of item sets. Like if I am trying to find L2, then what I use is the L1 subset. So I join L1 with L1 to find out the Lk. So this new set which is generated by joining is termed as Ck. Now after joining, what I require is I use the a priori property. So this Ck is a superset of Lk. It contains all the items. Now in all those items may not be frequent. So what is required is using the a priori property, I remove those items which are not frequent and those are included in Ck. So we remove those items and this reduces the size of the Ck. So any k minus 1 item set that is not frequent cannot be a subset of k item set. So this is the a priori property. So let us try to learn this a priori algorithm with the help of an example. So here you see an example database from transaction T100 to T900, and here we see a list of several items like I1, I2, I5, I2. So that this means that in a transaction T100, I1, I2 and I5 items are brought together. In the transaction T200, I2, I4 were brought together.